So, last day we started looking at how do you come up with the equation to describe a pattern. So a pattern could look like a picture where you got to do some counting. It could look like a little statement that describes how the pattern's changing. Or it could be just be a set of values in a table, right? All describing a pattern. You just got to come up with an equation that lets you go from one side of the table to the other. That's the equation relating the two things together, right? Our pattern for equation of a line is written up on the board. Is y is equal to mx plus b. They all follow that format, right? But we use appropriate letters for whatever the scenario is. So in our question, we don't have y's and x's. We have d's and t's in this first question. So are we going, remember the equation is y equals. So are we going d equals or t equals? T, right? Remember our table set up as x, y. So instead of y equals, we're going to have t equals. All right? Then we needed to figure out two numbers, right? So we have a number, like there's a coefficient in front of our x. In this case, we're using the letter d. Then plus or minus another number, right? The number, the coefficient in front, describes the pattern. How do you notice the values changing? They go up by 5. So this is going up by 5 plus 5 each time, right? So the coefficient tells us for every 1 increase in d, t goes up by 5. Right? So we got half of the equation figured out. The next half of the equation is the constant that makes this whole thing work. So all we do is take our temporary equation so far. We test it out with one of the spots here. So I usually just take the first one. It doesn't matter which one you take. So right now, our equation is 5d. So if I plug in 0 into my equation, what do I get? For this spot, 5 times 0, I get 0. But my answer, oops, should have been 11. So I need to make an adjustment to our equation to make it work. Just add 11, right? 0 plus 11 equals 11. That is our equation. Now, it's easy to make a mistake with patterns, right? Did you pick the right pattern? Sometimes you make a mistake, so you just check it with another spot on the table. So pick any spot, 1, 2, or 3. Just check the equation again, see if it's working. Pick one. Which one? 3. So we're going to take spot 3 on their table. We're going to write down our equation, our full equation this time. 5d plus 11. I'm going to stick in the 3 this time. All right, and we get 5 times 3 is 15 plus 11. So 15 plus 11 is 26. And it worked. That's it. All right? Let's do it 2 more times. Okay? So, start off with writing down an equation, beginning half of it. Y equals. We don't have y's and x's, so is it C equals, R equals? R. So I'm going to do R equals. All right? Need a number, not x, C. Need a number in front of the C. Come on, switch. Plus or minus another number. The coefficient tells us the pattern. What do you notice about the pattern? What is it going up by? Or what is it going down by? Sorry? Do you have it, Jaden? It gets harder when there's negative numbers, right? And some decimals and stuff like that. Jaden? 1.7. Do you guys agree? Disagree? Okay. So, a lot of hesitation here, right? This question, you can see it easily in your mind. The numbers are whole numbers. In your mind, the arithmetic you're doing is finding the difference between the two numbers. 16 minus 11 is 5. 21 minus 16 is 5. So if you can't see the difference in your mind, use your calculator to do the difference. Yes? 1.5, right? So just to show it, here, Difference is second number minus first number, so you have negative 0.6 minus your first number, negative 2.1, 1.5. Right? So if you don't see it, just calculate it. Use your calculator to do the difference. Right? So this is going up by 1.5 plus 1.5 each time. It can go down sometimes as well. Right? And you can check it with another spot. You can check it down here if you wanted to. 2.4 minus 1.9 is 1.5. So that is our number in front of the C. Okay? So now, we need to figure out what the other number is. So we have 1.5C. We stick in our first value. 1.5 times 1 is 1.5. It's trickier, harder. We want it to be negative 2.1. What number are we, first of all, are we adding or subtracting to get to negative 2.1? Subtracting by what amount? 3.6. If you're not sure, do the difference calculation again. We want to go from here to here. We want to find the difference between these two numbers. So you go 1.5 minus negative 2.1, 3.6. That's the difference between these two numbers, right? So minus 3.6 gives us our negative 2.1. So our formula is minus 3.6. Right? Minus 3.6. Right? So you find another spot to test it out with. Where would you like to test it? Make sure we did it right, especially with 4. Right? So I'm going to test it right there. 1.5C minus 3.6. So I'm going to stick in the 4 this time and see if it works. So just grab your calculator. We go here. 1.5 times 4 minus 3.6. Does it equal 2.4? Yes, it does. So we did it right. Okay. So it's really important to do the second test. Okay. Last one before you guys go off to your assignment. X's and Y's makes it a little easier. So this is going to be y equals something x, right? What do you notice, Adam? Goes up by 6, so we should put a 6 here. Okay, so now we test it out. Make it work, 6x. We plug in the 1. 6 times 1 equals 6. What do we need to do? Plus 2. All right. Now let's try it with another spot. Don't write this down. This is not going to work out. Where are we going to test it out?
7.
With 7? Okay, so we go 6x plus 2. Don't write this down because it's not going to work out. Okay, so we stick in 6 times 7 plus 2. So we have 42 plus 2 equals 44. Good, try it, Adam. Okay, so it didn't work out this time. What's different about this question? Do you guys notice something different? Jaden? This is going up by 2. All right, so our coefficient is how much does this go up by or go down by for every 1 increase over here? So it's per 1 increase. This one is jumping 2. So for every 2 increase, it's going up by 6. For every 1 increase, how much is it going up by?
3.
3. Our coefficient should be 3. All right, so I'm going to erase all this. So we have to go 6 divided by 2 because it's jumping 2 times. So this is going up by 3 each time. For every 1 increase, it's going up by 3. Okay, So now we go 3x. We stick in the 1. 3 times 1, we get 3. It should have been 8. So what do we need to add? Plus 5. Plus 5 gives us 8. Plus 5 here. So now if we go back to the question 7, is what we did last time. 3x plus 5, right? We go 3 times 7 this time, plus 5. So you get 21 plus 5, which is 26. And it worked. All right? So these kind of little, most of the time, the questions will work nicely like we did here and the ones before. Occasionally, you may miss something in the pattern. So this is why I'm saying, hey, always, when you come up with the equation, just check it with another spot on the table. See if you didn't miss something, right? Either you counted things wrong or you missed it jumping by 2s. Checking it with another spot on the table will make sure you didn't make that mistake. All right? So that's it.